let's work through an example so we can see how this relativistic clock synchronization works. So here's the scenario. Anastasia is on Earth and Beowulf is on Mars. And at present, Mars is 2.1 times 10 to the 11 meters from Earth. Earth and Mars are not the same distance apart all the time. It depends on where they are in their relative orbits, but I looked it up, and today, April 6, 2020, this is the distance between Earth and Mars. So Anna sends a light signal to Beowulf, and she sends that light signal at exactly noon, according to her clock. And it arrives a little while later on Mars. And Beowulf, who also has a clock, a different clock from Anna, measures the time of arrival of that light flash. And what we want to know is, if Beowulf's clock is correctly synchronized with Anna's, what is the reading on his clock when the light flash arrives? So if the clocks are synchronized, they should measure the speed of light to be the speed of light. So we'll use that to figure out the time of arrival for the light flash for Beowulf. Okay. So what we want to do is convert this distance to light seconds, to special relativity units. So we'll do that with the conversion factor. That 1 light second is 3 times 10 to the 8 meters. And let's see, we can do this two ways. First, without a calculator, 2.1 times 10 to the 11 is the same as 21 times 10 to the 10. And then I divide by 3 times 10 to the 8. And this works out really nicely. 21 over 3 is 7. To deal with these exponents, we subtract. 10 minus 8 is 2. So this is 700 seconds. You could do the same thing on a calculator. 2.1 times 10 to the 11 divided by 3 times 10 to the 8 is 700. And let's see, I should mention or point out that this conversion factor, I know it's right because the meters cancel and I'm left with seconds. So the distance between Earth and Mars is 700 light seconds. So that means that if these clocks are synchronized, the time of arrival of the light flash for Beowulf should be 700 seconds after noon. Let's end just by converting this to something maybe a little more relatable. I'm going to convert this to minutes. In 1 minute, there are 60 seconds. There's another conversion factor. So let's see, 700 divided by 60 is 11.67. So that's almost 12 minutes. 11 and 2/3 minutes. 11 minutes, 40 seconds. So again, if these clocks are synchronized, they would have to measure the speed of light to be the speed of light. The distance between Earth and Mars is 11.67 seconds. Light travels at the speed of light, or 1 light second per second. And so if this clock is synchronized with that, it should read noon plus 11.67 seconds when the light flash arrives.